can explain the heater controller I built for this portable heater I have. It's natural gas powered. It can move around on the floor wherever, but concerned about it being left on and having the ability to turn it off by itself. So I added this electronic solenoid. It's a 12 volt DC solenoid, and it's running to this big cluster of wires. It's a Motino Arduino based controller, and it's hooked to a MOSFET that will pulse the power on and off really fast. So the reason I do that is because if you hook just the 12 volts on to the solenoid here, it'll get very hot. It needs a lot of current to start up, maybe between 2 and 3 amps, but then it only needs about, I've tested it down to, let's say, 200 milliamperes to stay on. So that's very low power. So what I do is I start the power up using software. So in the code that I wrote for this, it can focus there. In the code, what we do is we use the analog write and set it to 255, which is full on power for 100 milliseconds. And then we take it down to 25, which is really only a duty cycle of about 10%. So it's really only getting power 10% of the time, but it's cycling on and off very fast at a rate of 3.9 kilohertz. So what I did with the Arduino is I hooked the scope to the output pin so I could measure what the MOSFET was getting, if it was really getting 3.9 kilohertz pulses or not. So I'll turn it on and demonstrate it real quick. This button here, if it takes a short press, it'll turn on. If you hold and press for longer than 2 seconds, it'll turn off. So here's the on. You heard the solenoid snap there. There's 212 milliamperes. Solenoid's on. What I discovered is the default PWM frequency is 500 hertz, and when I was pulsing it, it was making the solenoid squeal at a constant tone. So I had to experiment with the different frequencies and see at what point would I not hear a whine or a whistle. So here I've got the pilot light lit, and I'll just leave that like that. Jump back over to the oscilloscope. You can see we've got this square wave here, and in the fine print it actually tells you it's 3.92 kilohertz. So anyway, that's how that works. If you want to turn it off, like I said, you just push and hold this button until it goes dim. Like that. And no more pilot light. So I'm going to button this project up. Hope you enjoyed it.